optimum gain I can have per stage. So we have seen that if we are going to have more number of stages, the bandwidth is going to reduce, the gain is going to increase. So that should be a strategy to say that I need to have an optimum gain per stage. So even though the bandwidth is reducing and gain is increasing, you always remember the gain bandwidth product will always be constant for a given amplifier. So we are going to find the number of stages for which the overall gain is also decent. The bandwidth is also very good. So I am going to take that as capital G is the individual gain, and G power 1 by N is the gain after cascading N stages. So the single stage bandwidth will be omega T by G power 1 by N. And omega T, if you want to find the total bandwidth, you have to multiply by root of ln 2 by root of n. So that is coming from here. See here, root of 1 by n ln 2. So this square root term is there, right? So that you have to multiply. So this corresponds to the maximum number of stages will be n is equal to 2 ln g. So number of the optimum number of stages is n is equal to 2 ln g. So total bandwidth finally is given by this expression. So 0.357 omega t by root of ln g. So we can see that the overall bandwidth is proportional to 1 by logarithm of g. So it is very insensitive. So in fact, the product of bandwidth and square root of log of gain is constant here. So usually BW into T is constant for a single stage amplifier. But here, if you see, BW into root of ln G is going to be constant. So it is bandwidth into square root of log is going to be constant.